In 2018, it was reported that Australia alone had generated approximately 67 million tonnes of waste, with only 58% of that waste being recycled or used to generate energy. The rest gets sent to landfill, which has a detrimental effect on the environment. Plastic is the least recycled material in Australia, with only 9.4% of waste plastic recycled between 2017 and 2018. Plastics were identified as a low-hanging fruit in an attempt to improve recycling rates, ultimately exhibiting that these rates can be drastically improved, especially on a local level. Through this, we saw an opportunity to reduce the amount of plastic that gets sent to landfill in the local Illawarra area, with the potential to greatly expand nationally through the means of the Schroeder idea. The opportunity was also presented to us to work with the Illawarra Local Aboriginal Land Council on this project. The Illawarra Aboriginal Land Council represents the Aboriginal community residing in the Illawarra region of New South Wales. They support and protect the interests of the Aboriginal community and must be included in any design relating to the management of land or water systems in the Illawarra. They presented us with a design brief to make a product that aimed at reducing waste production in a waste stream, while also conforming to their values of caring for country, support self-determination of Aboriginal people, and supporting community well-being.
Our group, drawing inspiration from the design brief, client report, and background research, have decided to create a device which both shreds and extrudes common plastic types into 3D printing filament. The Schroeder, short for shredder and extruder, will do this efficiently while meeting the design brief. The team originally wanted to only make 3D printing filament out of recycled plastics, but our group then developed the idea and decided to make a machine, or part of the machine, which creates the 3D printing filament. The shredder is the first part of the machine, which is split into 3 further parts. The shredder was designed by the group and will be made out of recycled AISI 304 stainless steel. The middle section of the shredder is where all the plastic is to be shredded. This section consists of the casing and 4 rotating shredding shafts, with a couple of motors which will be added. The 2 shafts on the top are slightly larger than the 2 shafts on the bottom. All the shafts are rotating towards the center of the machine, so plastic items can be shredded efficiently. These shafts and the machine is all 1 meter long, so a large volume of plastic is able to be processed in this machine. The 2 other sections of the machine are the top and the bottom sections. The top section is purposely designed to be tall and of a complex nature, so it is difficult to become stuck in the machine or to have a body part get into the shredder. There is also a command paddle where the stop button can easily be pressed as it is sticking out, and the start button is hard to be pressed because it is sunk in easily. Both these features add to the safety of the product. The extruder is the second part of the machine. This part is highly complex, and the group believes that purchasing this from an exterior source is the best alternative. If provided with more time, our group will attempt to create our own extruder. The cost of this extruder was included in the cost-benefit analysis, and the calculated returns from selling the filament made this investment worthwhile. Amy will be looking to the feasibility of the design after the uni, who will be addressing the design and how that addresses the client values.
Producing a sustainable design, considering the values of the Aboriginal community, has been the top priority of our team. Therefore, environmental, social, and economic sustainability of the design has been thoroughly considered. The 3D printing model will be engineered utilizing PEHD, PVC plastics, and stainless steel. All of these materials will be extracted from landfills. By doing so, our goal is to help reduce the accumulation of waste in landfills, leading to the prevention of environmental pollution. What's more, stainless steel is actually an eco-friendly material which is 100% toxin-free and recyclable. We are aware that our client highly values caring for country, self-determination of the Aboriginal individuals, and community well-being. The shredder will have a great positive impact on the environment as well as a society. It will provide a platform for young Aboriginal people to test out their ideas while improving the quality of education. It will also produce many career paths and job opportunities, promoting financial independence. The Schroeder is one of the few products in the market that endorses the concept of circular economy. The product will be manufactured from waste, and at the end of its life period, we hope to recycle it. The team was mindful of ethics and the morals that needed to be followed when producing this design. In order to maintain trust and loyalty between our engineers and the Aboriginal community, as well as all the other stakeholders, we have made sure to demonstrate integrity, practice competently in order to produce a sustainable and innovative design. Next, Amy will talk about the financial aspect of the Schroeder.
The group have identified an opportunity for the recycled filament. Australia has lagged behind the rest of the world with adoption of 3D technology, however, are now in a strong growth phase. The team is looking to capitalise on this. The market size and demand is important as the Schroeder will produce 3D filament, which will be sold to produce a profit. One of the driving reasons for growth in the 3D printing industry in Australia is the increase in accessibility to 3D printers for individuals and businesses. The team undertook research into 3D printers currently available on the market. These two examples from Kogan show the affordability of 3D printers. The easier access means there will be an increasing need for 3D filament. Another driving reason for high rates of growth is the use of 3D printers in education. The development of the concept of a makerspace has increased demand for 3D printers and filament. There are over 300 makerspaces located across Australia in universities. UAW in particular will be a stakeholder focus of the team as they value innovation and sustainability. They would prefer to use recycled filament over virgin filament. 3D filament is typically sold by the kilo. With some research into sale prices of 3D filament, the average price for a 1 kilogram spool of ABS or PLA was $30 per kilo. The production cost for larger scale operations was around $12 per kilo. The net profit of $18 was a 60% profit margin. The team came to the conclusion that the profit margin and market for 3D filament meant this design was worthwhile pursuing. The team undertook a cost-benefit analysis into the Schroeder. The overall costs broken down in the table were estimated to be around $60,000 per year. The machine is estimated to run for 5 years. The benefits identified were difficult to place a monetary value on. However, the team came to the conclusion that these benefits would exceed the ongoing costs. The key benefits included the empowerment of Aboriginal people through jobs and investment of profits into their communities, as well as the improvement in educational resources. Overall, the product shows viability and feasibility in its design. It meets the design brief criteria and addresses the client values and needs.